Alright, so this video is going to just be a quick one on integrals of trig functions. It's pretty much an extension of 5.2. I'm just going to go straight into it, into some examples, just to show kind of how to approach these, and then I have a few, like just a little chart that shows summarizes all of the different trig function integrations, or at least the 6 basic ones. So this first one, we want to take the integral of secant squared x over tangent x dx. There's nothing we could really simplify right from the beginning, so we'll just do a u substitution. We'll make u equal to tangent x, differentiate that, and what do you know, we get secant squared x dx as our du, so that could be substituted for there, so that could be substituted right here, and we get 1 over u du. Recall that our rules for natural log integration was the natural log of u plus c. Plug our u substitution back into the equation, and we get the natural log of tangent x plus c as our answer. Second example, find the integral of tangent x dx. Well, there's nothing we could simplify. There's nothing we could do a u substitution with right now. So first thing I would do is just separate it into sine x over cosine x dx. Now we could see that perhaps we can make a u substitution, so we'll do it with this cosine. Whenever you do a u substitution, just always think to try substituting out the denominator first. Most of the time it's going to be the denominator that needs to be substituted for u if a u substitution needs to be made. So if you differentiate, if you differentiate cosine of x, that's negative sine x dx. We have a sine x dx, but we don't have this negative, so we can just divide both sides by -1. And now we can substitute that in. So we've got negative, I just pulled the negative out front, times 1 over our u in this case was cosine of x du. So now that's negative times the natural log of, for our u was cosine x in this problem, plus c. Now with that example, I can lead into this next section where I pretty much just summarize the 6 basic trig function integrals. The integral of sine u du is just the integral of sine of u is negative cosine of u. Integral of cosine of u is sine of u. Integral of tangent of u is negative natural log times the cosine of u. And you can see that we just proved that one in this second example right here. The integral of cotangent of u is natural log of sine of u. The integral of cosecant of u is negative times the natural log of cosecant of u plus cotangent of u. And then integral of secant of u equals the natural log of secant of u plus tangent of u. And don't forget that these are all indefinite integrals, so of course I've got the plus c on every single one. And I've also got the absolute value bars. So just one more example. For this one we want to solve the solve the differential equation. So first thing we'll do is just multiply both sides by dx. when it says solve the differential equation, what it's asking is pretty much to get y equals some function. So now we can integrate both sides. The integral cancels with the change in the y with the derivative, so we just get y on this side equals, and then for this one we've got tangent of 2x dx. So we're going to have to make a u substitution on this 2x so that we can try to get this rule number 3 right here. So u equals 2x, du over dx equals 2, and then du over 2 equals dx. So now I can rewrite this as 1/2. Since it's a constant, I pulled it out to the front, times the integral of tangent of u. We made a u substitution for that 2x dx. Y equals 1/2. From our rules, we learned that the integral of tangent of u du, so it's supposed to be a u, tangent of u du is negative natural log of cosine of u and then plus c. Do some simplifying and I get negative 1/2 times the natural log of the absolute value of cosine. U is 2x in this problem, plus c. And there's our answer. So, pretty straightforward for trig functions. Hardest part is probably just remembering these 6 integrals. If you can, I would highly recommend committing those to memory as best as possible. Some of these, like tangent, it was pretty easy to get to. It was pretty easy to prove it and find out what it came to be, but some of these are a little bit harder to do, like the secant u du one is to prove that one requires a method that not many people would think of right off the top of their head. So I just memorized these 6 things. Yeah, so there's 5.2.